All right, section 5.4, completing the square. So our objectives for 5.4 of completing the square is to solve quadratic equations by completing the square and writing quadratic equations in vertex form. So there are some steps we need to take before we get to there. The square root property, all right, you have this on the handout already. If you want to solve a quadratic equation, you can take the square root of both sides of the equation. So everything on either side of the equal sign. You always need to remember that you need to consider the positive and negative roots. So when you take the square root of a value, so you have x squared equals 15. When you take the square root of both sides, you have a positive and negative square root value. Okay. Also, when you have x squared and you take the square root of it, the square root and the squared cancel each other out, so you're left with x. And we've been dealing with that with the stuff that we just finished up with in 5.3. Okay. If x squared equals a and a is a non-negative real number, then when you take the square root of both sides, you get x equals positive and negative square root of a. And you'll see that through working with these. All right, so our first example, we're going to solve the equations by using the square root property, which you have a copy of. It was on the previous slide. All right, so we have 4x squared plus 11 equals 59. We want to subtract 11 from both sides. In doing that, we end up with 4x squared equals 48. I want to simplify this down as far as we can go, so we're going to divide both sides by 4. In doing that, you get x squared equals 12. We can now do the square root property, take the square root of both sides. The square root of x squared is x. And then remember, it's positive and negative, plus or minus the square root of 12. From here, you're just simplifying. You need to break down the square root of 12. The square root of 12 breaks down into the square root of 4 times the square root of 3, because 4 times 3 is 12. All right, square root of 4, square root of 3. Why am I doing that? This is stuff we did in the first chapter beginning of the school year. But the square root of 4 is a perfect square and breaks down to 2. So then we get x equals plus or minus 2 square roots of 3. This is in its simplest form right here. When you write this, what you're really saying is x equals 2 square roots of 3 and x equals negative 2 square roots of 3. After you then found you took the square root and found what your x equals, you can also go back and check it to make sure you're right, just like we do everything else. Okay? So to check it, we're going to plug in 2 square roots of 3 and negative 2 square roots of 3. When you square 2 square roots of 3, this is 2 times the square root of 3. This squared goes to the 2, so 2 squared is 4, and square root of 3 squared is 3. So it's 4 times 3 plus 11. 4 times 3 is 12. 4 times 12 is 48. 48 plus 11 equals 59. So that one checks out. Do the same thing with negative 2 square roots of 3. All right? The negative 2 gets distributed to the negative 2, so you're squaring negative 2. Negative 2 times negative 2 is positive 4. Square root of 3 squared is 3. So you end up with the exact same situation that we had over here. 4 times 3 is 12. 12 times 4 is 48. 48 plus 11 is 59. 59 equals 59. We did it right. Yay for us. So this is your now you try. So go ahead and work on this. This is your starting equation. Enter it in online. Example 2, we're doing the same thing. We're solving equations by using the square root property, but now if you notice, I have an x squared term, an x term, and 2 constant terms. Okay, this is where your trained eye is going to come in handy. The stuff we did in 5.3, identifying special roots. All right, so if you look at x squared plus 12x plus 36, perfect square, x squared, perfect square, 36. Okay, this is a perfect square trinomial, so I can factor it down. The square root of x squared is x, the square root of 36 is 6. 6 times x is 6x. I always multiply it by 2. I double it. That gives me 12x. That's how I know it's a perfect square trinomial. From there, I write out what it is equivalent to. Okay? It is x plus 6, the quantity squared. So now I can take the square root of both sides. Now I'm back to the square root property. Right? The x plus 6 squared, this is stuff we did in 5.3. This was the second day of 5-3. Okay? Take the square root of both sides, you end up with x plus 6 equals positive and negative square roots of 28. Remember, positive and negative, you need the plus minus. From there, you're going to move the 6 over, so you're going to subtract 6 from both sides. Gives you x equals negative plus or minus the square root of 28. From here, now we're just simplifying down 28. Okay, we're looking at it, you need to pull out the largest perfect square. The largest perfect square in 28 is 4. So it breaks down to the square root of 4 times the square root of 7, because 4 times 7 is 28. We can simplify it further. The square root of 4 is equivalent to 2. So I get x equals negative 6 plus or minus 2 square roots of 7, which is the same as writing it out as x equals negative 6 plus 2 square roots of 7, and x equals negative 6 minus 2 square roots of 7. From there, you also want to check. Okay, make sure you're right. So we're going to plug it back in, both terms, all right? Or you can write plus or minus. I would start using a calculator at this point, because if you're looking at what we have down here, negative 6 plus 2 square roots of 7 all squared, okay? Use a calculator to do these computations. All right, when you do the math, it will end up equaling 28. All right, these setup both equal 28. That's what we needed it to be equivalent to. So make sure you're using a calculator. Make sure you enter everything in properly, especially for down here that you're putting negative 6 minus 2 square roots of 7 all in the parentheses before you're squaring it. All right, that's going to be the important part to make sure your check works. And this is your now you try. If you check your work, you will know whether you're right or not. If you're not, go back and find your mistake. If you're right, if it checks out, enter it in online, you know you're done, you know you're right. We move on from there. Woo! Math. Go team.